Perfect. So good morning, good afternoon, good evening. Thanks for joining this week's Antrea community meeting. And we have quite a good agenda for today. We have at least 3 topics. And we will start with a discussion of the multicast auto discovery design. And that will be done by Wenning. And then we have Hong Liang that will talk with us about benchmark results for Antrea Proxy with the TC Flower, and then a discussion of approaches of proxy based on IP tables versus TC Flower. So therefore, without much further ado, let's get started with today's agenda. It seems that there are no other proposed topics, but feel free to propose anything else if there is anything else that you'd like to discuss, and we can get started. So Wenning, whenever you're ready, please go ahead.
Sure, let's share my screen first. Okay. I want to share the multicast design with some follow-up questions. The first is for the multicast group discovery. We originally want to discover the multicast group using a CRD, but it is not following the generic solutions for multicast. So we have changed the discovery solution to using the packet in and the packet out for the multicast group auto discovery. To discover the multicast group, first the Antrea agent should send OpenFlow entry on the web bridge to require the HMP message to send to the controller, I mean the Antrea agent. And then Antrea agent will pass the multicast group from the message. And second, Antrea agents periodically to send generic HMP query message to OS. It is using the packet out mechanism. The message is forwarding normal in the OS bridge. Then the local pods will receive the HMP query, and then they will report its packet group in the HMP report message. Having the OpenFlow entries we set up in the step 1, the HMP report message will be sent to the Antrea agent, and then Antrea agent could pass the group from the packet. We want Antrea agent to support the HMP report message with 3 versions. I mean version 1, 2, and 3. But we don't expect to implement the HMP v3 fully in the first release. It is because some soft-specific group records in the message, and I think it will be much cost in the coding. So to support fully the HMP v3, we will put it in the next release. But for the first release version, we could support to pass the group address from either V1, V2, or V3. Here is an example for the OpenFlow entries to allow the HMP packet to send to controller. We require the matching the network protocol with HMP message, and we require the destination network address to be 2024.0.0.22, which is used in HMP v3. And we match the destination address with the 0.2, which means all routers. Both 2 OpenFlow entries will be installed on the OS to let Antrea agent receive the HMP report message. And for the actions, we use controller and the normal action. For the first controller is to packet in the message, And for normal is to let the OS to learn the AgentMP message, and the OS could use multicast snooping feature. For Antrea agent, after it has received the AgentMP report message, it has processed the message in the following logic. First, if it is new group found from the message, Antrea agent will add it into its local cache. Antrea agent maintains the local cache with the multicast group and the last probe time. For the first time found the group address, it is added into the local cache, and Antrea agent will configure the transport interface to join the multicast group. Then for the physical switch or router, it could forward the multicast traffic to the node. And if the multicast group is an existing one, Antrea agent only updates the last probe time of the entry in the local cache. And after receiving the packet message for the response time, Antrea agent will loop in the local cache and find the stale multicast group entry. Then it will remove it from the local cache and require the transport interface to leave the group. If Antrea agent has received an AgentMP group specific, if the Antrea agent has received a leave group message, it will send out AgentMP group specific query message. If no membership report has received for the target group, Antrea agent will process it as the last group member and remove the group from the cache and configure the support interface to leave the group. Above all is for the auto discovery solution for multicast traffic. And then multicast group discovery. And for the multicast traffic forwarding, it is almost the same as what we have designed in the last meeting. We still use the OS multicast snooping feature, and we will progress the open flow entries to forward the multicast traffic to local pods, and we forward the multicast traffic if it is to the Antrea gateway interface if it is sent out from the local pods. Then Antrea agent also configure the multicast routing entry on the host. For the group for the multicast group which is found from local pods, it will add a multicast routing entry like on the host like this. It will require the source address with the pod address and the target group info which is what it has found, and it required the packet is forwarded from the Antrea gateway 0 to the transport interface. And as for the external multicast traffic, Antrea agent will leverage the AgentMP message no cache message sent out from the Linux kernel, and Antrea agent passes the source address from the message and configure the routing entry on the host to forward the packet from the transport interface or external interfaces to the Antrea gateway. So the packet could be forwarded to the local pods. It is for the routing entry configuration. And for the first release of multicast feature, we will support the no in-cap mode. But for in-cap mode, it will be implemented in the next version because of the multicast info is not able to share between different nodes in in-cap mode if we don't use other central mechanisms like Antrea controller. It is for the design for multicast traffic. I think it is on my part. Do you have any questions to discuss? Hello.
Thanks, Wenning. Thanks for your presentation. No, I do not have any question. Is there any other question from the community?
I guess just a quick question. If I remember correctly, and I see it at the end of the document, you said that IGMP version 3 is not going to be fully supported. I mean, I don't know much about multicast, but do you know, can you explain why IGMP v3 is not going to be supported at first? And is it a big issue, or do you think IGMP v2 is the most common version of the protocol in use?
It is because for the IGMP v3, some group specific, not group, some source specific group record is introduced, and it means that for IGMP v3, multicast client only receives the multicast traffic from the specific sources, but not all sources. As we don't want to differentiate the sources of the multicast traffic in first release, so we don't want to support this feature. It is why we don't plan to, we don't mean full support for IGMP v3. But this requirement, this feature is only introduced in IGMP v3, but not included in v2. So we don't say that IGMP v2 is not fully supported. We will support IGMP v2.
Okay, and by default, does like recent Linux distributions use like IGMP v2, for example? Or do they use IGMP v3, or it depends on the application?
I don't think we need to configure the IGMP v2, v3, or v1 in the configuration. It is supported in Antrea agent code. And I don't mean that for the IGMP v3, a source-specific message, we don't support it.
So do we not support IGMP v3 at all, or we only support IGMP v3 if sources are not provided?
We support part of IGMP v3. I mean,
okay.
we.
Yeah, sorry, go ahead. Yeah.
No, nothing to add it. You can go ahead.
Okay, so okay, thanks.
Wenning, I think I'm just thinking probably finally we still need to consider IGMP v3 and the source IP of the group.
Yeah, I think we will finally support it, but it should be a long term. I think it might have something similar like the multicast service network policy or some security requirements.
Right.
So I don't plan to support it in the first release only.
Okay, that makes sense to me.
Any other questions?
Not much. I mean, I also don't know a bunch about multicast, so I'm mostly learning here. Is there any plan for you to include this in the specific Antrea release? Is this at the moment just a design discussion, or are you considering implementation for the next Antrea release?
We plan to start coding after this community meeting, and I think we plan to have the first release in Antrea 1.4, maybe.
Thanks. That would be great. Thank you.
Okay.
Okay. Is there any other question concerning Multicast? Great. And so therefore we can now move to Antrea Proxy, where I believe Hongliang has some very cool numbers to show. Hongliang, please go ahead.
Okay. Oh, thanks. Wait a minute. Sorry, can you see the screen? Oh,
Yes.
okay, thanks. Hello, guys. I will first introduce the new design of Antrea Proxy 4, not with Linux TC, but IP tables, and I make a new request. First, the new design is much simpler. Is much simple. For node-pod, we just need an IP set, two IP table entries and a routing entry. One IP set is used to store node-pod IP pod protocol information, and the IP set is used as the destination for these two IP tables entries. Chain entry output is for package from localhost, and chain entry per routing is for package from remote. The masked packets will be deleted to a virtual service IP address. This one, and the package will be routed to Antrea gateway finally. Then in OS pipeline, this design is almost the same as Linux TC. Okay, this is the new design. Next, I will introduce the benchmark. Okay, guys.
Sorry, super quick question, Hongliang. So we're not using TC at all anymore? Sorry, I haven't been following the pull request too closely.
Oh, I see. We can see the benchmark to explain the question. Okay. There are three clusters. First, the first two are Antrea Proxy 4, which can support service from outside of the cluster. For this data, there are 70 services, and we can see the test data. This is the latest test data, and when testing these two group data, Antrea Proxy, Kubi Proxy is removed, and for every cases, I have tested 10 times and removed the highest and the lowest one. We can see that when there are 70 services for Antrea Proxy implemented by IP tables, or Antrea Proxy implemented by TC. For TCP stream, it's almost about 5% performance degree. But Antrea Proxy implemented by IP tables is a little better. For UDP stream, they are a little better than Antrea Proxy default without removing Kubi proxy. For TCP CRR, Antrea Proxy implemented by IP tables or Linux TC is all a little better than the default. And for TCP-RR, a little performance degree. Next, there are many services. For example, 2,100 services. We can see that the TCP stream is not changed a lot. Also, about 5% performance degree. UDP stream is almost the same, and TCP CRR, we can see that the Antrea Proxy full are much better, because this test will create a new TCP connection for every transaction, and there are about 2,000 services. Antrea Proxy default uses Kubi proxy to do DNAT, and the time complexity for searching IP tables is linearable, while Antrea Proxy 4 is huzzing. For TCP-RR, it's almost the same. We can see overall for the benchmark result, we can see that the Antrea Proxy for implemented by IP tables is almost the same as Antrea Proxy implemented by TC. And
I think we need to clarify one thing, that it's not Antrea Proxy is implemented by IP tables or TC. It's just the traffic redirection is implemented by IP tables or TC.
Yeah.
The service load balancing is all of the scenario. In all of the scenarios, the service load balancing is still handled by OpenWSwitch.
Okay, thanks. That's more exactly. For summarize, I think just for NodePod, for the new design, NodePod is just implemented by IP set, two IP table entries and one routing entry. Load balancer is also just need routing entries for every ingress IP. But for Linux TC, the config is much complicated. We need to add filters to every interface for every IP addresses, and we also need to add a lot of filters on entry gateway interface to redirect the replied packets. For load balancer, we also need the TC rules to redirect the packets from remote client. Okay, that's all. Any questions?
I think to further answer Antonio's question, that the reason why we introduced the TC to handle the traffic redirection is that we thought it would be simpler and clear to handle the traffic redirection, because the packets will be redirected to OpenWSwitch directly without going through the Linux networking stack. But it turns out that it actually introduced many complicated mechanisms. For example, for the multiple IP per interface case or multiple interfaces case, we have to install many TC filters in every interface. For example, if you have 3 external interfaces, we will do the same thing 3 times. And if you have 3 IPs on the interface, then the TC flower rules will be 3 times than 1 IP case. That's one complexity. And another is how the reply traffic will be handled, because when the open switch output the response to Antrea gateway interface, we will need to figure out which interface, which external interface we need to redirect to. So it introduces some long flow to handle this case, and it's a little complicated too. And by switching to app tables, it turns out that the performance is not affected a lot. As you can see that in some cases, it's even better than TC redirection, or at least not much worse than it. And we can still benefit from the advantage of open switch handling the TCP CRR. As you can see that when there are more than 2,000 services, regardless of the redirection mechanism, we can still get much better metrics than Q-Proxy, the TCP for the TCP CR metrics. So that's why we are considering switch back to IP tables based redirection mechanism.
Thanks for the clarification. Out of curiosity, do you know why in the last benchmark TCP RR, it seems that TC is actually degrading faster than the IP tables implementation? Do you know why? You know, I can see 0.9, so 10% for TC and about 5% for IP tables.
The TC result, the benchmark of TC is always not very stable.
Okay.
Yeah, I was observing the same. The variance for TC seems to be higher than the variance for IP tables. I don't know if this is something that we need to expect with the TC, or it's like just a byproduct of the testing.
Oh yeah, I see there is a widespread, especially for that test from 7700 to 9200. Yeah. Okay.
I have a question regarding what Chan just said about why initially TC was chosen over IP tables for redirection. You say that in this way we are bypassing the Linux networking stack, but does this also mean that with the IP tables we will be doing more kernel context switches?
We need to maintain the connection track on host because we do DNAT on the host.
Okay.
This one.
The thing is that if we enable full Antrea Proxy, then in theory there will not be many IP tables rules on in the root network namespace. So the overhead should be small. Unlike when Q-Proxy handles this, it will have many IP tables rules, so it will degrade a lot.
Makes sense. And did you have the chance also to measure other metrics of when doing this test, like for instance, if there is any significant difference in CPU usage or in latency? I don't think there should be any difference in latency, but maybe CPU usage might be a factor.
Oh, sorry, I forgot. This test I forgot to record the CPU uses and the memory uses.
No problem. It was just a curiosity.
As I remove the cookie proxy, the memory usage reduces.
Yeah, definitely. Definitely, yes.
CPU circles, CPU uses in previous test, not this test, the CPU usage degrades, but not just a little.
I see.
Not very obvious.
I see. Thanks. Thanks for the clarification. All right. So, in light of these results, are we recommending using IP tables for redirecting traffic, because it seems that it will lead to an easier implementation, a more manageable implementation? Is that correct?
Yeah. It's much simple.
Cool. Antonin, Junjun, any additional feedback on this?
No, not from me.
Cool.
No, I'm good.
Perfect. Is there any other question, curiosity from the community regarding these results, or the overall observations regarding TC flower versus IP tables for traffic redirection?
Yeah, I'm just thinking. Even Chen and I discussed, and Chen feel even we switch to eBPF, probably is no much performance gains compared to TC. But I'm still thinking maybe we should consider eBPF sometime later. At least in theory, we can say we can use eBPF to accelerate the traffic redirection and bypass the host TCP stack. And it can be one story for eBPF plus Antrea better together. Yeah, but it's more for later consideration.
Yeah, that would be surely an interesting thing to explore. Cool. Any other question on this topic? I'll wait 15 seconds.
Just for Jianjian's further suggestion, I think it makes sense, and maybe we could have the basic implementation based on IP tables, which could handle all traffic from all interfaces. And if TC, eBPF, or XDP can really accelerate the redirection, maybe we could enable it on a major external interface that we assume that most of the incoming external traffic should come from. Right? Does it make sense?
Yeah, that's also one strategy I thought about. Probably it makes sense to cover the most important cases. But I'm also thinking if we want to recommend eBPF when eBPF is supported by the host OS, I'm not sure we want to cover more cases. But anyway, I'll probably let's think about it later, I guess. Maybe we should do some tests to see if can really have performance gains or not.
Sure.
Cool. And so it seems that we are at the end of the planned topics for today's meeting. Is there Anything else that we would like to discuss for today?
Hong Liang, I just have one more question. So we still plan to include this IP set plus IP tables based implementation in our current release, right?
Pardon, I didn't get the first
I mean,
part.
since we changed the approach from TC to IP tables, do we
Okay.
still plan to include the feature in this release?
Oh, I have finished the PR, and then if you are available, could you please help review the? Okay, I see the 2599 2099 the PR number. I have finished the code.
Yeah, I saw the PR. Okay, at least it's ready for you.
Yes.
So, just so everyone, we are all on the same page. Is the PR already updated, or are you going to update the PR soon?
Yeah. Yes, the PR is ready, and but it needs code review.
Okay, thanks. And I think that with this we have exhausted this topic. We still have about 20 minutes, so if there is any other topic that you would like to bring up for discussion, please go ahead. Perfect. It appears therefore that this is all for today. So I would like to thank everyone for joining. And as usual, it's been a very good conversation. Thanks a lot, Wenning and Hong Liang, for your presentations. And we'll meet again in 2 weeks' time. So thanks again for joining, and I wish everyone a great day, a good morning, good afternoon, and a good evening.
Thank you. Bye.
Thanks.
Thank
Bye.
you. Bye bye.